respected policymakers, industry pioneers, technology architects, and esteemed guests. Very good afternoon. I am GSVL Rao, Director and CISO from STPI. It's a cordial invitation to everybody for this summit. And I would introduce all the dignitaries on the dais, one after another, soon after my speech. I would like to brief about the actual context, and I would like to set the context and the stage first, and then strategically I will invite the dignitaries to give their opinion on various topics. Okay? Good afternoon once again. Nowadays, artificial intelligence today dominating conversations across boardrooms, parliaments, universities, and startups, and many more situations. We speak models, we speak automation, we speak about productive gains and innovation cycles. But rarely we pause to reflect on the fundamental truth. AI is only powerful as its infrastructure that is sustaining it. Behind every generative model, every predictive engine, every real-time analytic platform, there exists a complex ecosystem of data centers, cloud platforms, high-performance compute, and energy systems and cooling technologies, and many more in the backend. If large language models are the brain, retrieval augmented generation gives the memory. AI agents are going to give them the hands to act. Model context protocols give them a nervous system connecting the tools, data, and environments. In a nutshell, AI may be the new brain, but the infrastructure is the new nervous system for the entire AI ecosystem. So how do we build such an entire ecosystem responsibly at a national scale? Because scaling is not just a simple thing. Because scaling without security becomes a risk. Scaling without sustainability becomes the burden. Scale without sovereignty becomes the dependence. Today, India is standing at a defining moment. We are no longer passive adopters of global technologies. We are increasing the emphasis on sustainability, and we are actively architecting the digital capacity. The expansion of hyperscale data centers, rapid cloud adoption, the push towards sovereignty and the infrastructure, and increase in the emphasis, sustainability in all signals a mature AI ecosystem. But growth brings the responsibility also. How do we design data centers that are secure and sovereign? How do we democratize AI through cloud without compromising the trust? How do we manage immense energy and thermal demands to compute incentive systems? And how do we ensure infrastructure growth aligns with the environmental commitments? So these are all not the engineering questions. These are all the strategic questions we all should answer. These are all the economic questions we need to think of. These are all the environmental questions we need to mind. And they are all the national capacity questions as well. So the story of AI in India will not be written only on the code or algorithms, but it will be written in megawatts, in fire roads, in cooling innovations, in regulatory frameworks, and architectural choices which we make today. Because I strongly believe in it, yesterday's decisions are going to shape your today, and today's decisions are going to shape our future. So it becomes resilience, it becomes competitiveness, it becomes sovereignty, it becomes our destiny towards empowering the AI for the people, for the planet, and for the progress. Today's session invites us to think beyond models, to think beyond the terms of systems, think beyond the compute, think in terms of capacity, think beyond innovation, and think in terms of responsibility. So with this context set, I would like to invite the the speaker for the first session on the topic, designing data centers for scale, security, and sovereignty. So in this situation, on this moment, ladies and gentlemen, I am privileged to invite the visionary first generation entrepreneur, Mr. Piyush Prakash Chandra Somani, who founded ESDS in 2005 at the age of 26 and clear purpose to build technology institutions and digital infrastructure that long-term sustainable and national value. So please join me warmly welcoming Mr. Piyush onto the stage to share his thoughts and insights on the designing the data center for scale, security, and sovereignty.
Thank you, Venkat. All the esteemed panelists here and the audience, colleagues who all are here to hear our views. Obviously, most of us are here from the data center background, and Mr. Venkat from STPI and a couple of other colleagues who are here from STPI. So definitely we have to understand what all is happening in AI across the world, because for most of the people, when we talk in India, for them AI means ChatGPT, and then a couple of people from enterprises or who are working in different offices, they think that Copilot or Claude is all about AI, but we don't understand what exactly globally is happening in AI. And if we recently open all the newspapers, Department of War in America has mandated all the American AI companies to share each and every data parameter with them. Now, globally, whatever data AI companies, so only one company is resisting that. I don't know how long they'll be able to resist that. 5 other AI companies, they have confirmed that any data that America wants, Department of War wants, that data would be given to them. Unrestricted access to any data required by Department of War. And what kind of impact this makes on the rest of the world? What kind of impact does it make on India? Can India, so obviously we all are vulnerable because we share so much of our data with the AI tools. Now we cannot live without the AI tools. All the tools that we are using today, be it the ChatGPT, Copilot, Gemini, Claude, some people have been using Quen, Kimi K2, KLM, DeepSeek. Multiple other tools are also there. There are tools about the tools also. There would be multiple tools that ride above some of these tools, and they gives AI solutions to us. But what are the limitations? Why India doesn't have any of its tools which is as popular as some of these tools? So we have to understand the infra part here. We all are here from the data center vertical, cloud vertical, and infra seems to be a limitation at the moment for India. Now, what is the limitation in terms of infra? So I've been traveling aggressively all over world. I've been to across the data centers in the Middle East, data center in the Southeast Asia, and data centers in Europe. I have been there to see data centers across multiple countries in Europe. So the number of GPUs which are deployed in each and every data center in Europe is probably 10 times, 20 times of total GPUs deployed in India. So the latest GPU series that we have been talking about, be it a B200, B300, GB200, GB300, we have only a handful of those in India, and outside India, every data center is deploying 100,000 of those. So imagine the size at which they are deploying. Obviously, the cost is phenomenal. India's total public infrastructure spending in next 12 months is going to be $147 billion. And each of these companies on the top, be it an OpenAI or Amazon or Microsoft or Gemini, they all are going to do upwards of $200 billion each in the next 12 months' time. In next 18 to 24 months time, globally $1.5 trillion to $1.8 trillion is going to be invested only in AI infra. So the difference in the scale is huge, and India will have to figure out its own way. Either we come up with a chip, or either we come up with a some kind of an hardware which helps us to optimize the models, so bring the size of the models, reduce the size of the models, launch the models, develop the models on a lesser number of GPUs, or probably we invent our own TPUs, or we invent our future quantum chips. But at the moment, we have to accept the reality that India needs to think differently, put capital, bring that capital to deploy large-scale GPU infra inside India. Opportunity, now what we have brought in the budget recently, we are inviting foreign data center companies or foreign AI companies to come and deploy their data centers in India. That can be a game changer. We should definitely aspire. I personally think so that some of these companies which are not interested to unconditionally share every citizen's data, every global person's data with Department of War, may be invited to come and set up their operations. How we can do that in India is something government will have to figure out. But if we don't do something in this next 2 years' time, 3 years' time, the opportunity can be lost. And obviously, we have to think out of the box. It is very, very important that by 2028, 2029, we have sovereign AI clusters, and that sovereign AI cluster powers sovereign AI chatbots, and sovereign AI chatbots should be in a position to come up, help us with. The way we are now thinking of Sarvam, so Government of India is promoting Sarvam, how can we have 3-4 such models of our own? And look at China. All the 4 top chatbots that have come out of China, they are improving every day. They are putting infra at a scale, and inside China, outside China, everywhere they are putting infra at scale. China has reached 100 gigawatts now, overall data center capacity. India, data center wise, it is just 1.5 gigawatt. America is like more than 60, 70 gigawatts right now. Europe has planned to deploy more than 50 gigawatts in next 3 years, 4 years time. Look at the numbers where Europe, where China, where America is, and where we are. So we have to definitely gear up. I don't want to say that we are far behind in the game, because we are the biggest consumers of the AI right now. And someone says that to become a great leader, you have to become a great follower, obviously. So we are definitely in that race where we are religiously following up whatever is happening. And we believe that all these investments that are going in AI infra, as soon as China comes and democratize the hardware, the way AI is democratizing software and AI is democratizing technology, same way China is in the process of democratizing hardware. How can India collaborate with China? How can India come up with its own hardware so that the future AI is powered from the knowledge and from the intellect of Indian people is a question to be asked to ourselves. I'll leave the audience with these questions. Thank you.
Thank you, Mr. Piyush. That's an insightful presentation. You have clearly articulated how sovereign, scalable, and secure infrastructure is not an optional. It is a foundational to the India's ambition too. Thank you. So once the infrastructure is built, intelligence must be delivered, right? The delivery should be efficiently, escalatorily, and elastically, and securely. Once the physical data center is designed, the next layer is cloud enablement. Because cloud virtualizes the infrastructure, cloud democratizes the AI access, and cloud enables elastic scaling. This is the transition from hardware foundation to a service delivery layer. To gain deeper insights as a second session, AI at our fingertips, delivering intelligent services through cloud. It is my pleasure to invite Mr. Sunando, Chief Revenue Officer of Yotta, to address the gathering. With over 25 years of rich experience in the service providing industry across networks, data centers, and cloud, Mr. Sunando brings deep strategic and operational expertise. Thank you.
Is there any way we can have that deck in a smaller frame? Clear the...
It is covering the
Sorry, some technical challenges. Okay, so we are finally ready to go. Thank you for your patience. So hi everyone, my name is Shunanda Bhattacharya. I'm the Chief Revenue Officer at Yotta. What I'll do is, since the larger subject was AI in action, so I'll actually talk about a very interesting case study in the second half of my presentation. First, I'll tell you a bit about Yotta and what Yotta is doing. And then I'll talk about one of the most interesting stories of cloud repatriation, which is what Yotta has done with Bhashini. And I'll take you through that journey. Right? Okay, so I'll spend just 5 minutes talking about a bit about Yotta because I don't know how many of you are familiar.
ये जो 3 डॉट है
Fine. Yeah, thank you. Okay, so Yotta is what we would like to call a ground to cloud player. We run our own data centers. We run 2 hyperscale data centers in Mumbai and Delhi NCR. These are 160 megawatt scalable to 2 gigawatts. And then we have a small data center in GIFT City in Gujarat also. It is completely built on our own land. Our own team has built and operates the data center. Even the power distribution to these data centers are managed by the group company. We are all part of the Hirandani group. And then on top of that, we have built our own cloud and AI stack. We are one of the largest partners of NVIDIA globally, the largest in India currently. And we deliver an end-to-end integrated story to our customers. We have 2 primary brands, Shakti and Yantra. Shakti Cloud is our AI cloud. Here we offer bare metal cloud, virtual machines, containers, even a full-fledged inferencing platform. So all range of AI services are available. And similarly, we have Yantra Cloud, which is a hyperscale non-AI compute, general compute platform on which you can get infrastructure as a service and multiple platform as a service. across our portfolio, apart from Shakti and Yantra, we also have very interesting services like Drishticam, which is an AI surveillance platform, which allows you to manage population scale surveillance and do analytics on top of that. And then we also have something called Suraksha Smart Cybersecurity, where we offer a portfolio of managed cybersecurity services. We are also have two major PPP public-private partnerships. First one is with NIC, where we operate the NGC cloud, or better known as Meghraj 2. And in that partnership, two of the cloud regions are operated by us. And similarly, we have a partnership with STPI, where we work with them and co-partner on the Ananta Cloud, which is STPI's own cloud offering. Today, Shakti Cloud is our primary focus, given this is an AI summit. And here, we are one of the 6 reference architecture AI clouds from NVIDIA across the world. 4 are in US, 2 outside India, and proudly one of them is in India. It's currently a 10,000 GPU AI factory, one of the 50 fastest supercomputers in the world, 16 exaflops. And it is scaling up to 50,000 GPUs by end of this year across various generations. Piyush just spoke about Blackwell, so we'll have B200s, GB300s coming into the same AI factory down the line. So Yota is essentially driving the AI power in the country, ensuring that we are coming close to world players and delivering the required AI infrastructure that is needed in India. As Piyush rightly said, there's a huge shortage currently. And interestingly, most of the names that Piyush mentioned, which is Sarvam, BharatGen, Socket, they're all building their models on our GPUs. So India is going to come up with many, many sovereign large language and small language models in this year. And most of that work is happening on Yota GPUs. So now coming to the case study. So we are presented with a very interesting problem about a year back. Bhashini, all of you would know, it's part of Ministry of IT, Digital India mission. And it is a multilingual AI platform which enables you to do real-time translation across almost 30 languages currently. And they were running on one of the hyperscalers, the global leaders. And they were facing a lot of performance bottlenecks, a lot of latency issues, and cost was really going out of hand. Any of you who have used hyperscalers would know it's not cheap, it's super expensive. So over a period of 6 to 9 months, I'm going to take you through a very interesting case study now, where how we enabled a globally hyperscale use case to move from a global hyperscaler completely 100% onto Yota, a sovereign AI infrastructure provider. So now, when they were considering this migration, there were 4 key challenges which were highlighted by Bhashini to us. First and foremost was availability of GPUs. Most of the hyperscalers still don't have GPUs in quantity in India. If you want them to provide you GPUs, you have to go outside India. That leads to data sovereignty issues, that lead to latency issues, so on and so forth. We were able to solve that because our entire AI factory is running from our data center in Mumbai currently. Then they were facing challenges around observability. Whatever their entire data flow, how they were managing their application, they were not able to get deep observability in the stack, which is leading to restricted analysis of the data, and then a lot of dependency on information coming in from the hyperscaler on the restoration times, etc. So what we did was we designed Bhashini as a scalable digital public infrastructure. Bhashini is going to be used by many, many departments of the government of India and the state governments. So therefore, it has to be robust, it has to be massively scalable, it has to be able to take on significantly high burst capabilities. And auto scale was a native requirement of the platform. So we built it on few core engineering principles. First and foremost, zero vendor lock-in. One of the challenges they were facing on the hyperscaler was they were locked into a lot of the native PaaS services of the hyperscalers. And I talk to many startups, I talk to many enterprises who, once they have deployed on a hyperscaler, they find it very difficult to move away because of the lock-in on the PaaS services. So one of the things they very expressly said they want to move away from any kind of vendor lock-in to largely an open source based stack. So that was the first thing. Secondly, the underlay abstractions or applications remain agnostic to the infrastructure, where they are able to design the infrastructure completely independent of the application was very critical. The design of the cloud has to be completely SLA driven, where be it bandwidth, be it IOPS, be it the compute architecture is completely SLA driven. And everything has to be in a managed service model. Why they want to move away from PaaS, they don't want to let go of managed services. So it was very critical that whatever environment we were building for them had to be completely managed. So very challenging problem statement that we are presented with. Most interestingly, you could see a plethora of locked-in platforms over here, which we had to move away to an open source stack. Now, this was the biggest challenge that our team came up with. And because at Yotta, we have our in-house cloud engineering team of 150 plus people, we were able to create open source alternatives of many locked-in cloud native hyperscale providers. And this is something very critical because one of the things that I would urge most cloud providers in India to work on is building this capability in-house, where they're able to enable customers to move away from locked-in technologies. So along with the general purpose cloud, there was a huge AI requirement because of MLOps and AI platform. So be it the inferencing request and then going on to getting the request queue into the GPU cluster, that entire architecture had to be integrated back into the cloud. So what was the performance benefit that finally Bhashini got out of it? So earlier they were running on legacy T4 GPUs on the hyperscaler, and where we moved them onto modern H100 GPUs with TensorRT. So on one of the use cases, index trans to the processing time dropped from 4 seconds to 0.4 seconds, and indic ASR processing time dropped from 9 seconds to 300 milliseconds. So 10x to 30x speed improvement was observed by the Bhashini team on migrating to Yotta GPUs. The last challenge that we solved was the data log. There were over 3.3 billion tiny data log files which were there, and they had to move this entirely off the hyperscalers to our storage. Now to do this, one option was do a direct object-to-object copy, which if any of you have tried to do that, it's a very, very time-consuming, it will take months. So what we did was we created a parallel file storage staging area and first copied to that and then did a copy from there. Also, a lot of customers today don't know, but if you are moving fully away from a hyperscaler, you actually end up paying 0 egress charges to the hyperscaler for 30 days. If you go and tell the hyperscaler that we're completely moving away, there's a 0 egress charge. So we took benefit of that feature to reduce the billing for Bhashini and enable them to move completely away through the PFS staging. And most important was the data analytics part, which was replacing Databricks with Apache Spark, proprietary notebooks with Jupyter, and from a managed warehouse service to Apache Hive. Now this transition also significantly reduced the licensing cost, not just the cloud infrastructure cost, but the licensing cost. And overall, we were able to reduce their cloud billing by 40% while giving a 30% overall performance impact on the entire stack. This is a QR code you can scan. We have published a very detailed engineering report where it's a 200-page report. Whatever I showed you in 10 slides, it is detailed in 200 pages. It is something that all of you can go through, understand, and what are the capabilities that Indian cloud providers now have. So those days are gone where there's a lack of confidence in Indian providers because of lack of depth of engineering capabilities. Today, Indian providers are building that capability. They already have that entire capability available with them. So it's truly time for action, and we are ready for the action. Thank you.
Thank you, Mr. Sunendo. Thank you. Thank you, Mr. Sunando. The demonstration is really good. Your perspective on the elastic scalability and accessibility truly highlights the democratization of the compute. So now I invite Mr. Dennis, the Chief Products Officer of Submer, an expert in the high-performance computing, and he joined Submer in November 2025 as a Chief Products Officer. Please come.
Hello? Is that okay? Can you hear me? Somewhere, the first one. Okay, so let me start. So I'm counting the time. So Jean-Marc Denet, 40 years in high-performance computing. I launched the HPC activity at Bull, the French supercomputer manufacturer, which is also very active in India with the National Computing Mission. And during my time at Bull, I designed some of the largest supercomputers in the world, including the data center around. So after a long career, I came to Submer to align the company to the new strategy that we have decided, which is to move from a pure cooling technology with immersive cooling to a full end-to-end AI data center solution company. Our goal is to bring to the market turnkey data centers, modular data centers as a product, in order that the time between the start of the data center installation on a field, green field, and the time you can turn on the key to start the operation is reduced as much as possible. Thanks to 2 points. The data center becomes a product. Second point, we see the data center as a whole, the building, the electricity, the pipes, the transformers, the chillers, the production of cold water, of cold things when it is needed, and where the usual data center providers stop at the foot of the rack. We enter the rack. We go inside the rack. We bring cooling inside the rack in the servers with all the possible cooling technologies you can find on the market. So in this short presentation, I'm going to explain quickly the main challenges that we are facing in the production of AI data centers. So the cooling is, well, I'm not talking about the financial aspect, which is the real #1 consideration at stake when we have to build AI data centers. But beyond the financial considerations, cooling is the very, very first issue to be solved. Why? Very simple. First, the semiconductor industry is reaching, let's say, a limit in terms of density. Today, the most advanced GPU, CPU, whatever, let's say, compute engine are produced in 2 nanometers at TSMC. And next one will be 1.9, 1.8, but there is a limit somewhere, and we are very close to this limit. And the production of heat is just incredible. The most advanced today, the most advanced GPU from NVIDIA are in the range of 700, 1,000 watts. The next gen will be in the range of 2,000 watts. The next gen will be in the range of 4,000 watts, which is giant. And we must pack all of them in servers, in racks. Density, the energy density is becoming a real issue. So how to address that? So we have the solution for that, and I guess we'll have the opportunity to talk about that during the open session. So we also observe, and this is the third point, the second point, that with the power density in the rack, the very classical data center, which are air-cooled for most of them today, and this is called the brownfield, the inherited data centers, they cannot cool beyond 40 kilowatts. So the super advanced air-cooled solution can reach 45, maybe 50 kilowatts, maybe a bit more. But this is super complex because air is not very good to transport the heat from one place to the other. It's not the right way to go. So we must go to liquid cooling to go beyond the air cooling solution. And with liquid cooling, today, especially with a direct-to-chip solution, we believe that going to 500 kilowatts in a rack is possible. It doesn't mean this is a standard 19-inch rack. It could be a giant rack, like the NVL72 from NVIDIA, or the new Helios rack from AMD. Oh, by the way, I was earlier this afternoon going through the conference, and I saw the Helios rack from AMD. It's giant, it's big. So I strongly encourage you to have a look. In order you can see what the rack of the future could look like for the direct-to-chip solutions. And going that, we are reaching the core problem. This is maximum density, well, because of all the components in the racks, and the cooling of the racks. So today, if we want to cool such a crazy density per rack, you cannot, on the first hand, design your data center. On the second hand, buy your servers with a specific cooling solution, because you need to bridge the two together. And this is for this reason we have decided to bring cooling from the data center itself to the rack, to the server, to the compute engine itself. And there is not many companies around the world who are able to do that. So we have decided to move this way beyond the question of producing data centers as a standard products off the shelf with very simple configuration rules. So all of that, this is mostly for the training phase. When we'll talk about inference, the distribution of the power could be a bit different. The point is that today, the big names that has been mentioned earlier, like OpenAI, like Amazon, like Azure, they bring the training phase and the inference phase together in the same servers. This is why the question of density is still there. So with the solutions we, how to move. With the solutions we have designed for AI and for AI scale, which is in the range of 40-ish megawatt IT load for a standard data center, and you can move to a gigawatt-ish data center in the close future. First, you need to use the electricity just to produce science, to run your AI model or whatever. Using electricity to produce cold, well, it's not very smart. This is why the question of PUE is very central in this discussion. And with our liquid cool solution, we have estimated we can go on the cooling considerations. The transformer phases and the different transformer stages is a different question that I will not address today. The question of having a super low PUE as close as possible to 1 is key. On this aspect, we have designed solution where we can run in free cooling up to 45, even more, 45 degrees Celsius, and we estimate that we can reach 48 degrees Celsius with a very reasonable density per rack, something like several hundreds of kilowatts, meaning that we can have a POE that is as low as 1.03 or something like that. It cannot be 1 because we have to move some liquid, and for that we need pumps, and you need electricity for the pumps. Something that is absolutely crucial for the future, especially for the next generations, is water. So cooling data centers with no water consumption is mandatory. It's even not an option. So we have solutions using 0 water. Not a drop of water is used or is evaporated. It's not me. Speed of deployment of the data center is crucial for the operators, for the company needing the data center, because they are spending billions. They put billions of dollars on the table at day one. So the return on investment is delayed if the time to get the data center up and running is 1 year, 2 years, or even more. So considering that the right move is to see the data center as a product with all the components being off the shelf that you can plug together very easily, is the way to go to accelerate the time to operation for the creation of your data center. And with the solutions we have developed and we have proven over the last 10 years with immersive cooling, this is a fact, that with our liquid cooled solution, we improve the MTBF. This is the mean time between faults, meaning there are less errors, a better reliability. So for the training phase, where you need to have hundreds of thousands of GPUs working together for a single application, when you have millions of memory DIMMs, when you have tens of thousands of servers, hundreds of thousands of servers working together, if you have one failure somewhere, just a memory DIMM, boom, the whole calculation is down, and you need to restart your training phase. So this is a waste of time, a waste of money. With our liquid cooled solution, you improve the reliability of your solution, so you gain a lot at the operational level for obtaining the training of your giant models. And this is especially true with the models having billions of parameters to be trained. And I want to extend the discussion beyond the data center, beyond the core data center that everybody is talking about today. And maybe that will be a point for the discussion as well. The next frontier is not the core data center, because it's going to reach some limit. The market will be saturated in the next 5 years in terms of giant data centers. Because, well, who can offer to spend 10 billion in one data center? And the sky is not the limit. There will be some hard limit of usage. So the next limit is coming with the era of robotics. With people start talking about robotics, really. And this is the next limit. I mean the edge. Why? Because with the rise of localized AI operations, with robots in the factories, with autonomous vehicles, the response time for having the AI answering to a request, a sensor in a car is detecting there is something on the road. The answer must come in the next fraction of a second. It must be localized, meaning you need to have some very decent AI calculation on AI answer local in an edge data center. That could be in an existing building, brownfield. That could be in a brand new greenfield edge data center. And by the way, the typical size of a data center for the edge computing is between 0.5 megawatt to 2 megawatts. There is no official definition about that. But what we observe when we engage with the telco, because the telco are the next kings in the era of edge AI, because they are the people who know how to move the data very quickly from the endpoint, where the data is generated and where you need an answer, to the other levels, from the endpoint to the edge, from the edge to the core. back, the telco have the key for addressing this question. So when we discuss with them, they talk very openly on the fact that they need thousands of edge data centers, thousands. So the question of productizing the edge data centers, off-the-shelf products, with everything in one box, in one container. The compute servers, the cooling solutions, the electrical transformers, the chillers or the dry coolers, all of that in one. And this is where, again, our strategy to cool the equipment from the generation of the data center, from the creation of the data center on the cooling up to inside the rack, inside the server, is the way to go for edge computing. So in summary, and we are already at the conclusion, I would say that, as I have explained, cooling is the definitive bottleneck for moving forward in the era of AI. And for solving that, liquid cooling and the different variants of liquid cooling is a must to address the demand of AI. And ultimately, if we look at beyond the core data centers, and this is well managed, well understood at the technology level, people just start thinking about the next frontier, the next move, which is at the edge with the edge data centers. So we have a global strategy addressing all the components of an end-to-end solution from the core to the edge up to the endpoint. And that will be my conclusion for today. And I thank you for your time.
Thank you, Mr. Dennis. That is really a nice one. Cooling is not just a side topic. Definitely, it is a central to all the viability. Moving on to the efficiency within the data center, we all know that efficiency within the data center is vital. But where does the energy comes from? Where does the energy comes from? Cooling addresses the operational efficiency, but energy sourcing addresses environmental responsibility. Now, let us expand our focus on data center efficiency towards planetary responsibility. The next session topic is AI that runs clean, green energy for the smarter data centers. Ladies and gentlemen, it's my pleasure to invite Mr. Ankit Sarai, Director and CEO, Techno Digital, onto the stage.
I hope I'm audible. So the topic given to me was green energy for data centers and how can we make data centers more sustainable in their operations. So let me start with a little different perception to what we believe data centers to be. So I was very lucky to have been part of PTC 26 in the beginning of this year. And out of many points of discussions, I think the 2 points which stood out, which was on top of everyone's mind, was one, they are power guzzling in nature. Communities have to fight for resources for the same very resource which data centers consume, and they are not wanted. So I couldn't believe what I was hearing, but most of the developed country like US, where we are talking about 50 gigawatt of data centers, communities don't want data centers in their pockets, in their localities, because they believe the cost of power is increasing because they have to compete for the same very power. The cost of water is increasing. It is it is increasing the pollution during construction. The accidents are increasing because the number of trailers and trucks that are moving, kids don't have parks to play in, and prices of real estate is coming down in those locations. So that was one problem. The communities are against data centers in US. And second is, how do you get energy to them? How do you get so much of power when we are talking about a gigawatt of data center at each of these locations? Today, I met someone who's just starting a company in data, who's starting a company of developing data centers in US, and they're talking about the first data center as 900 megawatt. In India, we start with 10 megawatt, 15 megawatt, and probably a startup will talk 2 megawatt. So that's the scale, and then that's where the community is moving there. So these are just some numbers, you know, where US stands, and obviously we are going to be following some developed countries in the trajectory in which they are growing. So data centers are consuming about 176 terawatt hours in 2023, which is equivalent to 16 million homes. Projected consumption of 15% of US electricity by 2028. And we are talking 2028 in US. You know, in our couple of tier 1 cities, we are already consuming 15% of power. And by 2030, I believe those cities will touch 30%. And the reason why I'm talking about cities, because it is not about the power generating capacity of the country, it is about the transmission and the grid capacity of that city to distribute that power to the data center. It's the last mile connectivity which matters, not the entire generation capacity of the country, because that doesn't flow through the same grid. So yeah, so this is the challenge that data centers bring on the table when we don't plan for it, when we don't plan for it ahead of time, when we don't plan for it to be sustainable and green. But that is where Techno Digital has been able to bring a difference. And the reason is because of its pedigree, the parent company being Techno Electric and Engineering. We are a 40-year-old company in power infrastructure development. I can proudly say that 50% of power infrastructure in India has been built by Techno Electric. In terms of, let's say, if Power Grid owns 270 substations, then 160 have been built by us. In every power generating power plant of NTPC, Techno has had one role or the other to play. Today, we are executing smart meters in 5 states. We are also installing flue gas desulfurization projects for multiple GenCos. So we have a very strong pedigree in power, and we are listed on both BSE, NSE. We are debt-free. We've done more than 400 projects in India in last 4 decades as an EPC in power sector. And because of our pedigree in power, we felt that data centers should be the next where we should penetrate, where we should have our presence, because it is power guzzling in nature, and with our understanding of power, the differentiation is what we can bring in. And that's where the journey started for us. So how are we conscious about the challenges that the developed countries are facing, and what is it that Techno Digital is doing differently? I think I'll talk about our large-scale data centers later, but first and foremost is we are developing edge data centers in almost 102 cities in India in joint venture with RailTel Corporation of India Limited. And what these edge data centers do is, as we spoke about in the earlier presentation, that they bring compute closer to the user. But apart from that, it does one very interesting thing, that it distributes your power consumption across the country. So you're not dependent on one particular grid of a city. You're not particularly dependent on a grid of a state. And it brings down the cost of power, because you don't have to now string transmission lines from the generating point up to the consumption point, which is one single location. So let me give you an example. Virginia today alone has a capacity of, I think, 15 gigawatt. And the amount of transmission lines coming into Virginia is just increasing. It has made that area look horrible. The cost of power has increased because they are stringing transmission line right from generating point to Virginia again and again. And I'm sure we don't want it to happen in our tier 1 cities. And we don't even have the right of way for it to happen. So that is what edge data centers do. They distribute your power consumption. But what is it that we do differently in our large data centers? So let me come to our data center in Chennai. So it's our first data center. It's 36 megawatt. It's, I would say it's possibly the greenest data center that has come up in the country. It's water cooled. And most people will think that water cooled, you're consuming a lot more water. But let me say that, let me address it in 2 ways. You know, the amount of power consumed by a water cooled data center is 50% lesser than power consumed by air cooled. And to generate that 50% additional power for an air cooled data center, the thermal power plant on the other side is consuming a lot more water. So we have to look at the entire chain to understand how we save on water. So water-cooled data centers don't consume water. It is the thermal power plant which will end up consuming it. The second is that while being conscious about water consumption, we use these adiabatic cooling towers, which helped us bring the water consumption down by 75%. Not by 25, but 75%. So if a conventional cooling tower consumes, let's say, for our data center, it would have consumed 2,000 KLD of water. We are cooling it with only 500 KLD of water. So that's the number of water consumption has been brought down. Apart from that, you know, we are possibly the only data center which can guarantee a customer that the entire power that they will consume, out of which 85% will be green. And the reason is because we have sourced it right from the grid. We have sourced it right from the generating plants, and we guarantee our customers that whatever, if they consume 100 units, 85 units will be green. And this renewable energy that we are bringing into our data center is possibly at the lowest tariff for any data center in India. That is at 5.5 cents, which is 4.9 rupees a unit. I don't think any other data center can give you that tariff and guarantee 85% renewable energy. So this is how you plan for the future. This is how you can differentiate yourself to ensure that you're community friendly, society friendly, and data centers are not unwanted just the way it has become today in more developed countries. So thank you very much. Let me end there. Thank you.
Thank you, Mr. Ankit. That's really nice, and bringing up the sustainability dimension and India sharp focus on the planetary positions and all. That's really nice one. So let us have the discussion move forward, looking towards the people-centric conclusion. From the hyperscale cores to the distributed intelligence, the future of AI moves closer to the citizen. So the next and final session is on the topic, AI on the edge, bringing smart computer closer to people. It is my pleasure to invite Mr. Piyush Gupta, Vice President, Sales and Business Development, India and APAC, and the Middle East and world. So to address the gathering, I invite him. Is there any announcement? Okay. Sorry for the inconvenience. So Mr. Piyush Gupta is a distinguished leader with over 3 decades of experience across telecom, data centers, AI, and cloud. Mr. Piyush had led senior leadership roles in various organizations. And today, Walter, he is responsible for shaping and executing the regional go-to-market strategies, expanding the company enterprise footprint across the India, APAC, and Middle East. A cordial invitation to Mr. Piyush Goyal. Please come. Please, may I request Mr. Piyush Gupta to come onto the stage and give us some light on the edge AI Edge. Please, sir. साउंड नहीं आ रही है, देख लीजिए थोड़ी सी साउंड ये वाला छोटी सी नहीं आ रही है, देख लीजिए एक बार. Right, sir? Do you have any presentation or something?
So, good evening. Thank you STPI. Thank you Government of India for arranging this and inviting Vulture to this session. I am absolutely honored, delighted and privileged to be here in front of this August gathering and introduce Vulture to you and then subsequently talk about how Edge will dominate the scene in the days to come, especially around AI. So with this, I come right to the topic, which is AI on the edge, bringing smart compute closer to people. Before I start, I just want to know by the raise of hands, how many of you have heard of Vulture before entering this room or till now? Wow, that's very encouraging. When I used to do this around 6 months back, 1 or 2 hands would raise up, now at least 30%, and I hope by grace of God in the times to come, it will be resounding 100%. So that's the reason I am here. So Vulture was a developer-facing company, product-led growth for the last 20 years, and we crossed 100 million annual recurring revenue with zero sales, zero marketing, zero dilution of equity, zero outside capital, and remaining profitable. So with this distinction, last year we raised funds, Series A, company got a valuation of $3.5 billion. We raised $330 million through debt, equal amount through equity, and with that cash in bank, we appointed a team in Asia Pacific. They appointed me as the leader, and I am here to carry the motion forward. So by way of introduction, Vulture is the world's largest privately held cloud computing platform. Very recently, we got acknowledged by Gartner and the IDC. These are two global citations. So I want to bring to your kind attention, if you want to categorize the world of cloud into 3 major buckets. So one is the emerging leaders, which are Amazon, Google, Microsoft, and Alibaba from China, not so much of relevance to India. The other bucket consists of Tencent, Huawei, IBM, Oracle, and Vulture. And on the other side, you have the neo clouds like Lambda, Corby, OVH, Cloudflare, Nebius, and the others. So we have gone past that neo cloud status and now competing head to head with the hyperscaler, trying to claim our piece of sunshine under the sun. And I request all of you to espouse and look at us favorably as we go along in this journey. So look at this, 24 years of operating history, 220,000 paying customers around the world who consume Vulture every morning from 185 countries, from 32 data centers, of which 3 are in India, at Mumbai, New Delhi, NCR, and Bengaluru. And 90% of the world's GDP is not more than 40 milliseconds away. So that sets the tone for the edge to come in. Moving forward, more than 30% workloads are already residing on edge, and you will see this number going up as AI takes the center stage in our life. From compute, we will move to AI, real-time data generation, real-time inferencing, and edge will have a very, very potent role to play. By way of introduction, ours is a very simple cloud. It consists of 3 products, compute, GPU, both available in VM and bare metal version. And this is ably supported by Kubernetes, databases, storage, networking, and security at all levels. We serve globally scaled customers across CPU and GPU. You look at this Microsoft. The talking point here is Activision. The company was acquired by Microsoft. Call of Duty is name of the game. I'm sure many of you and your kids play that. Worldwide, since the year 2008, we are holding 14,000 bare metal server for Microsoft, for Activision. And in spite of the company being taken over by Microsoft, Activision as a use case continues to run on Vulture, because for this use case, this is a partner of choice. More compute, raw infra, high performance computing, all edge-like applications. And in spite of, because the other platform is very, very software heavy. More platform, more SaaS, more infra. So every time you virtualize and go to the infra. So here you have raw infra with very thin, minimal software. So that's our USP. Then others, AMD. AMD is an investor in Vulture also. Figure AI, Fireworks AI, Supermicro. All these customers are the ones who are almost impossible to go past technical, financial, and commercial due diligence. Just because the product is good and is cheap, it will not find its way into the AMD. Sony, Algolia, McAfee in India, Checkpoint, Airtel, Akasa, Athos. These are all very, very prominent, proud names. You can Google them, you will know more about them. and the pedigree I want to place for your kind attention through these names. This is the story I was telling you. Vulture crossed 100 million, which is around 900 crores annual recurring revenue in around 21-22, with 0 salesperson. Today, the headcount of the company is 338, and we have closed an order book of $500 million, which is orders which will be converted to revenue in the coming year. 0 sales, 0 dilution of equity, 0 capital, 0 marketing, remaining profitable. Outside of Vulture, only 4 companies in the world have done this. Slack, Atlassian, SolarWinds, and MailChimp. These are all very, very prominently known top SaaS companies, and we are possibly going to be making our headway into this foray very shortly. Now, coming straight to the topic, what will drive the edge? So these are the use cases which have been making prominence in the center stage in the industry. Technologies like IoT, 5G, AI, ML, AR, VR, Industry 4, now Industry 5. These are the guardrails, these are the fundamental technological shifts which will drive the traffic towards the edge. And telco and cloud partnership, as Sir said, that you need 1,000 edge data centers. It is impossible as a DC operator can create 1,000 edges. So it will be the telco tower which will be the edge. You will have edge on wheels moving forward. Not only edge, like a stadium like this, will have edge created here to run the seminar and edge dissolved when the show is over. So you will find, like you had carrier or a mobile tower coming and standing in Pragati Maidan, you will have an edge compute populated with such liquid cooling, come and parked in Pragati Maidan or Bharat Mandapam and go back when the show is over and come back again. So use cases I will tell you: media entertainment, e-commerce, video, gaming, ad tech, education tech, which is live coaching, fintech, autonomous vehicles, healthcare. Now in healthcare, where edge will take prominence is federated learning. Today the medical data is very, very difficult to come out of the hospital. Even if the law says yes, the doctor or the administrator is still skeptical, where will I go if I let the data out, even if it is anonymized and all of that. So what is happening is the edge compute boxes are coming to the hospital, picking up the patient data, training the model, leaving the data behind, only taking the code away, and enriching the model at the core, and then bring it back after a week and populate it further. And the whatever data this hospital guy is giving the drug discovery person is being monetized. Today, dead data had no value. Here there is a monetary value. Even patient data, patients are being monetized to share their medical reports, and that will be picked up at the edge, at the hospital, at the clinic, and not taken to a data center. And the model will be trained here in Mini, taken back to the core. Core will get enriched. The enriched model will come back to this hospital. So everybody benefits. Oil and gas, manufacturing, utilities, retail. Top use cases are transportation and logistics, warehouse, entertainment, healthcare, smart city, computer vision, surveillance, traffic challan, things like telediagnostic, autonomous cars, smart grid, predictive maintenance, virtualized radio, content delivery, smart homes, video analytics. All of this drones will consume edge and drive the use cases of edge with every passing day. So what, and all this will be, can be GPU, can be very high speed CPUs, but that is not the topic of discussion here. But edge is here to play and become bigger and bigger with every passing day. And this whole ecosystem, this slide is the main talking point of this entire talk. This was about gaming, I told you. We are hosting 100 plus AAA gaming titles since 2008, and all on the edge throughout the world. As Sir rightly said, edge has no direct formal definition, but anything between 300 kilowatt up to 5 megawatt is considered edge. Recently, hyperscalers created a new term called LZ, local zone. They used to have AZ, region, now it is an LZ. So LZ meaning edge is coming closer to the source. So bringing the compute closer to the point of data generation and data consumption. It can be of any size. And edge is also becoming richer and richer, bigger and bigger. This is about Vulture. You name the type of AI, and we have a story here. More relevant to this topic, inference edge platforms like Replicate, Together AI, then self-driving infrastructure, which we are doing through Helm AI and Pony. So these are the use cases where Vulture is driving the edge, or Vulture is sitting on the edge. But these are all very, very prestigious AI names, and we are in every vertical of the AI, and it's all here. Similarly, on the CPU side, you name the industry and Vulture as a customer. These are all top-of-the-line customers. Software, fintech, healthcare, telecom, Web3, gaming, managed services, security. With AMD and NVIDIA both we have a very deep and a very old partnership. So you name the GPU, we have it. Last year in GTC, when people were talking of B200, we had paying customers on B200 last year in March. This is AMD. So this is NVIDIA actually. B200, GS200, H100, H200, top of the line GPU at scale, megawatt quantity are available on NVIDIA, all available on Vultr infrastructure. Similarly, AMD, MI355, MI325, MI360X at ROCm ecosystem, and ROCm is ever evolving. And we have the latest versions in our library at all times. So this makes it a complete AI provider, edge being a part of the whole. Any CPU, any location. We have very good partnership with all the OEMs in the CPU community, so the chips come from where they come from, packaged in top-of-the-line OEM boxes and deployed around the world. And this is one thing I want to bring to your kind attention, which will talk about Vultr at scale. At this moment, as I speak to you, it fills my heart with pride and pleasure that Vultr is investing $1 million in Ohio at Springfield in a cluster, and we are bringing a 50 megawatt with 24,000 GPU chips online, which will happen between March and May of 2026. So this is, and such more clusters will keep happening, and India is not far in this journey. And to top it all, we have a beautiful marketplace where every SaaS company, every provider can come and integrate their product into Vultr, and together we all go to market. So with this, thank you so much for allowing me this, and any questions, anything you want to know, I am here for a few minutes.
Ladies and gentlemen, as we close, do we have any questions from the audience? Our speakers are ready to answer any of your questions if you have. So what we heard today is not just technology. It is all about alignment of purpose. India's AI future will not be accidental. It will be articulated and architected very soon. We are entering to an era where infrastructure is no longer invisible. It is strategic capital, and it is national capability as well. So on behalf of the summit, I extend my sincere gratitude to all our distinguished speakers for their candor, expertise, and strategic clarity. And thank you to the organizers for convening a platform that treats infrastructure not as a technical afterthought, but it is a national imperative. And thank you to each and every one of your participants here, because conversations like these shape the decisions that shape systems. End of the day, those decisions are going to shape our bright future. Thank you so much. Thank you. Jai Hind.